We will be looking at inequalities, how to represent them, and how to solve them. You've done linear inequalities before, but we will take this topic one step beyond that. First of all, let's consider how we represent inequalities. X is less than 3 can be represented in more than one way. First of all, we can use the number line. If we represent the number line like so, and we have 3 here, x less than 3 is represented by this region. We use an empty circle to indicate that 3 is not part of the solution. We also have what we call the interval notation. Where x belongs to, this means belongs to, an interval that ranges from negative infinity up to 3. And to indicate that 3 is not included, we use a square bracket turning its back to the 3 because it's not included. And with the negative infinity, because it is not a number, it is just a concept, it cannot be included because you never reach it anyway. So you have another bracket that has turned its back to the negative infinity. Also, we have set notation to represent the same inequality, and that would be the set of x such that x is less than 3 and x belongs to the set of the real numbers. Three different ideas to represent this inequality, and they are all conveying the same message. What's new is probably the interval notation. So let's look at another inequality. X is greater than or equal to 4. Using the number line, we have 4. And since x is greater than or equal to 4, this represents your solution. The circle is now filled in to indicate that 4 is included. Using interval notation, we say that x belongs to the interval from 4 to infinity. But in this case, 4 is included. So the square bracket that we draw is facing the 4 to indicate that it's included. And again, infinity is a concept, you never reach it, it's not a number, so the bracket is turning its back to the infinity. And using set notation, our solution set is x such that x is greater than or equal to 4, where x belongs to the set of real numbers. Consider this double inequality. We begin on the left hand with a smaller number, and on the upper hand we end with the bigger number. It matches the order of the numbers on the number line. So on the number line, this is 5 is not included, negative 2 is included, so this represents your solution on the number line. Using interval notation, x belongs to the interval from negative 2 to 5. Now obviously 5 is not included, so the square bracket will turn its back. Negative 2 is included, so the square bracket will face it. And using set notation, x is such that negative 2 is less than or equal to x, which is less than 5, and x belongs to the set of real numbers. Let's now consider the meaning of double inequalities. This means that 3 is less than or equal to x and x is less than or equal to 10. The meaning of a double inequality is that two inequalities are being met at the same time. And if we take each one separately, let's consider our number line. If this is 3 and this is 10, the first inequality, let's do that in blue. 3 is less than or equal to 10. In other words, x is greater than or equal to 3. So the 3 is included. And your solution set goes up to infinity. Let's consider x is less than or equal to 10. Let's do this in red. 10 is included. And x is less than 10. So this is your solution set. But there is an and in between. And the and means that the two inequalities must be met at the same time. So your solution set is this. And since the 3 is included and the 10 is included, then your solution set is this, is how it's represented on the number line. So you don't need the blue or the red. And again, we have one region from 3 to 10, and that's represented by one inequality. Alternatively, if, for example, you have this setup on the number line, let's do this as an open circle, then this implies that you have two regions. And the two regions, if they are both representing your solution set, then in this case, x is less than or equal to -5. This represents this region. And you have x is greater than 3. It represents this region. But because you want to take both of them, then there is an or in between. In this case, you cannot have the two inequalities occurring at the same time. You cannot have an and here because there's nothing in common. If there's an and here, then there's no solution. When you had an and in this case, you had an overlap. Since there's no overlap and you want both of them, then it's an or. Moving on to generalize, one interval on the number line is represented by one inequality, whether single or double. But if you have two intervals on the number line, then you need two inequalities with an or between them. Before we move on to solving inequalities, let's look at two important remarks. The first is that when you multiply or divide both sides of an inequality by a negative number, you should flip the inequality sign. For example, if you have negative 2x is less than 4, and you divide both sides by -2, this becomes x is greater than -2. And the reason is, well, look at this inequality. 3 is less than 4. But if you multiply both sides by a negative, consider -3 and -4. -3 is greater than -4. For this reason, remember to always flip the inequality sign if you divide or multiply both sides of the inequality by a negative. The other remark is when taking the reciprocal of both sides of an inequality, the inequality sign must be flipped. However, note that this only applies if both sides of the inequality are either both positive or both negative. For example, consider 1 over n is less than 0.5. And you know that n belongs to the set of positive integers. So you know that n is positive. Taking the reciprocal of both sides of this inequality gives you n is greater than 1 over 0.5 is 2. And therefore, you know that n is 3 or more. If n is 3, 1/3 is less than 0.5, 1/4 is less than 0.5, and so on. If both sides have different signs, for example, one is positive and the other is negative, even if you take the reciprocal of both sides of the inequality, the positive will still remain the greater side. Let's solve. We solve inequalities in very much the same way that we solve equations. Consider this linear inequality. We subtract 3 from both sides, giving us 2x is greater than or equal to 12, and then divide both sides by 2, giving us x is greater than or equal to 6. But here, if we subtract 5 from both sides, we get negative 3x is less than 7. Now we have to divide by the coefficient of x, which is negative 3. So we should be careful to flip the inequality sign because we're dividing by a negative number. And this is negative 7 over 3. Now let's consider this double inequality. It tells us that 2x plus 1 lies between 5 and 13 inclusive. The way to solve this is to subtract 1 from the 3 components of the inequality. So this gives us 4 is less than or equal to 2x, which is less than or equal to 12. Then dividing by 2 gives me 2 is less than or equal to x, which is less than or equal to 6. But this is a little bit more complicated. There are x terms throughout. So we have to remember that this double inequality is really a combination of two inequalities. The first is x plus 3 is less than or equal to 5x minus 13, and 5x minus 13 is less than 4x plus 20. So we must pay attention that the solution that we get here should be applicable, and the solution that's here should be applicable. Both solutions should be applicable at the same time. Let's see what this means. If we rearrange, we get 16 is less than or equal to 4x. Dividing both sides by 4 and starting with the x gives me x is greater than or equal to 4. Now going here, moving the 4x to this side gives me x is less than 33. Note that it's important that those two conditions are met together. It's an and. So we draw the number line. The first inequality, if this is the 4, then this is included, and everything that's value of 4 or more satisfies this inequality. We have another inequality at 33, but 33 is not included, and anything less than 33 satisfies this inequality. Now, where are they satisfied together, hence the and, from here to here. So it's one region on the number line. Therefore, we can write our answer as 4 is less than or equal to x, which is less than 33. And that would be your answer for this double inequality.